This is a 12 volt 10 watt LED floodlight, and I thought it'd be interesting to get one just to see what sort of circuitry is inside. I have to admit, at first I thought maybe they're just using a resistor, because typically the forward voltage of the LEDs will add up to 9 volts, maybe a bit higher as you push more current through it. And it was feasible that it could use something as simple as a resistor, although if you consider that if this was being used for vehicular use, then the full charge voltage of battery would be about 13.8 volts. You'd have to allow it for that, but still the resistor for that, but still have enough current, flowing at round about the 12 volt region. So it might make it a bit critical. However, I can tell you already this does not have a resistor in it. I can tell that from these meters, because this is displaying voltage, this is displaying current through the LED, and the LED at 8 volts is just starting to glow. Rather disappointingly, the middle LED is not lit yet, because it's one of these shonky LEDs with this sort of parasitic resistance across it, which means that initially the first two lights that light on this are the two outer ones in the middle row, and then after that the other LEDs start coming up and then the middle one comes up. So it's not a great LED, but let's turn the voltage up. So now the LEDs at about 8 volts, 8.6 volts are all lit, and it's starting to head towards 10 milliamps. As I increase the voltage to 9 volts, the current suddenly increases to about 40 milliamps. And as I increase it upwards, I'll take it right up to 12 in fact, which is its rated voltage. And at that, it's drawing 590 milliamps. Let's say 600 milliamps then, since it's just rolled over. Which means 12 volts times 0.6 equals, the 10 watt light is a 7.2 watt light. But that's okay. And if I increase the voltage further, the current increases initially and then suddenly drops off. So at about 12.24, you can actually see a sudden dip in the light. It suddenly cuts back down. It's like some extra stage of regulation is kicking in. So this is about the highest we're going to get. 12.29 times 0.67. Yeah, it's not going to, that's 8 watts, it's roughly at the moment. But as I turn it up to, say for instance, let's turn it up to, let's turn it up modestly high, because it's got regulation anyway. At 16 volts, 450 milliamps, so let's say 16.18 times 0.45, and it's still sitting down in the 7.2 watts region. So it's got a regulator in it, so let's pop the lid on it and see what that regulator looks like. I should just kill the power at the moment. People are critical about these little cheapy meters. I regard what it is just a basic cheap meter, this one here. And they're very cheap. You can get them on eBay for about 3 or 4 quid or something like that. They're really cheap. But, they're not super inaccurate. They're not up to the status of like an Amical or a Fluke or something like that. It's going to have modest accuracy. These things are a rough and ready meter. They're pretty acceptable for just fun use, but certainly I find them very useful for applications like this where you just want an extra meter, and the current was tallying up completely with my meter, the power supply up there, so they're a useful little extra meter. I shall actually just move this lead back away from the 10 amp range into the universal range. That way I won't have any little fuse blowing incidents. And we'll get this meter out of the way as well. And then pop the lid in this. If you're just getting into electronics, there's no, you don't have to go for luxury, top of the range equipment initially. You can start off small, and then as you appreciate it and as you want more accuracy, then you can move on to better meters if you get right into it. But to start off with, you don't have to break the bank. So those little meters there, as long as you're not poking them in mains voltage connections. But actually, I will say that, in the UK we've got fuses anyway in the plug, so it wouldn't be so dramatic, but it would probably blow the meter up if you stuck it across the mains while set to the current range. But you certainly don't want to use one of those dinky little meters in an industrial environment, because where there's a lot more power, if you do accidentally short bus bars or something with it, it would go bang. That wouldn't be very nice. So typical construction, it really is just one of these little lights. While we're on the subject, I was trying to remove this black stuff, this black paint, and I reckon that these lights are manufactured at the same places that of course make like metal halide lights and halogen lights. And this, I could not get this black stuff off. This also has what looks like a big skid mark in the back. What is that? It looks like it's had a power supply that's gone bang in it or something like that. It's just got this strange random skid. But either way, I could not get that off. It seems to be heat resistant, which would make sense given that, you know, if it's designed for something like a metal halide light fixture, it's going to get extremely hot inside. So I wonder if this is enamel that's physically baked onto the glass. I tried soaking it overnight. I tried various solvents. I tried acetone and other stuff. And then I tried soaking it in concentrated sodium hydroxide, thinking it would, like, you know, clear that off, because sodium hydroxide is extremely caustic and will remove a lot of paints, but it didn't. I'm not sure how to remove that. If I ground it off or buffed it off, it's going to scratch the glass. I wanted it off because I wanted to put bigger circuit boards inside it. Actually, I wanted to put a solar panel inside it. But that's not going to happen now. I think we're stuck with that. So I'm not seeing a lot in here. I can see a big void where the... Oh, there's the little power supply, the little driver. Or should I say regulator is probably a better description, since that's all it's really doing. It's limiting the current through the LED. Yeah, that's pretty simple, is it not? It's just really a little heat shrink module. I can see there's some sort of pointy connection here that's burst right through the sleeving, so it could make contact with the case. I'm not sure what that is yet. Let's open it up and find out. Maybe snips would be a better job for this. Chippy Chinese snips for this job. Try not to cut some components in half while I'm at it. There is what looks like an electrolytic here. Or is that a choke? No, it's an electrolytic. I say choke. I'm not sure if that translates too well, because in the UK a choke is another name for an inductor. It's just because it chokes the current. I guess it's an old-fashioned term. Well, this is a tiny circuit board. That is minute. It's got a full bridge rectifier on it. The little choke, the electrolytic capacitor, 220 microfarad, 25 volt. And then it's got that inevitable little chip, a 6-pin chip, which I shall just see if I can spot a number on it. It's a bit grubby. CL6807. CL6807. I'm going to check that up. I'm going to check that and see what it is, and I'll leave a note in the description below. It's really what you'd expect. It does make me wonder, you could make custom lights out of these, in the sense that let's actually just lop these leads right off and let's stick the power supply directly on that and see what voltage that LED actually lights at. So I'm going to crank the power supply back down. I'm not going to suddenly apply 16 volts across it. I think 8 volts is a good starting point. So where's the positive? Is over there. And negatives over there. Trying not to short both leads against the back of the case. Okay, at 8 volts it's drawing 7 milliamps. And turn the voltage up. If I'm going for the full 900 milliamps, let's go for the 900 milliamps through it and see, because that would be the point that it would be running at the full 10 watts, and we'll see what the voltage is across it. 900 milliamps, the voltage across it is 11.28, so you're not going to get much, you know, if you were trying to run this off 12 volts with just a resistor, that's too close. However, if you wanted to run it at a lower level, like that, which is still putting out a lot of light, that comes down to a more manageable sort of 9.7 volts. So you could consider using a resistor in there. At the simplest, you know, you could use a resistor rated for 13.8 volts, which is the peak of typically a car battery, a sealed lead acid battery will be charged up to about 13.8 volts. If you based it on the voltage of this being about, let's do the maths here. This is just doodles, just thoughts in my head. So supposing you started off at 13.8 volts, which is the maximum you're typically going to get, unless your battery charging system's gubbed, in which case it might go considerably higher and liberate lots of electrolyte out of your battery in the process as gas. The voltage of the LED is showing about 9.7 at about 300 milliamps. Let's see what power that is then. 9.7 times 0.28 actually. Yeah, just kicking the ass off 3 watts. So supposing, just out of interest then, we wanted to go for the full, you know what, I'm not going to, because the voltage is so close to 12 volts, let's turn this up to the 900 milliamps. Let's pretend that we're going to try and get it as a full 10 watt. Just let me know if I'm rambling too much. I am rambling, but that's okay. This is what I actually just experimentally do all the time. So that's dead on 900 milliamps, and it's 11.21 volts. So 11.2 volts. So 13.8. 13.8 minus the 11.2 volts means I have to drop about 2.6 volts across a resistor at 900 milliamps. R equals V over I, so that's 2.6 divided by 0.9 equals a resistor value of roughly, say, 3 ohms. 3 ohms. That would work. But what would happen as the battery voltage went down to, say, 12 volts? So let's turn this voltage down to, let me see now. Ooh, that's tricky. Right, I'm going to pause and just do the maths here for a moment. Okay, I stalled there because I suddenly realised that there were going to be 2 sliding variables. That as the voltage was reduced and the current went down, the actual voltage across the LEDs would change as well. So I thought the best way to test this would be to make a resistor up. And while I was paused there, I also checked up that chip that's on this, the CL6807. It's a 35 volt, 1 amp LED driver. That is its dedicated task. And you set the current with a resistor. You've got a logic level input option. There's a protection diode across it, the choke and the smoothing capacitor, and that is fundamentally it. And that makes me wonder if it's rated for 35 volts. A lorry voltage, the 24 volt you'd get in a lorry would be about 28 volts in reality if the battery is fully charged. The only weak point there is this capacitor is rated 25 volts, but having said that, 28 isn't too excessive. So possibly these lights would have worked with this little switching regulator on 24 volts. Possibly. I'm not saying I could guarantee that, but it does look like it from the rating of the components. However, back to what we've got in hand, I made this resistor up, which is it's 11 33 ohm resistors in parallel, because I didn't have any high power 3 ohm resistors, so that is 3 ohms, but rated almost but not quite 3 watts. And if I now enable the power supply here for, let's turn it up to 13.8 volts, the current is at the 900 milliamps that I was hoping for. So the entire dissipation of the fitting, including the resistors, which will be dissipating a modest amount at that, they'll be dissipating about 2.6 times, let's see, I was going to drop 2.6 volts times 0.9, it'll be dissipate, actually it's within the rating. That's alright, it's borderline within the rating of those resistors. But the power dissipation of the whole fitting with the resistors and the LED would be, oh that's bright by the way, 13.8 times 0.9 equals about 12 watts total. Keep in mind that some of those watts will be across the resistor. So the resistor is the LED is being run approximately 10 watts now. But what happens if I then turn the voltage down? Imagine it's on a vehicle's lead acid battery and it starts settling down to its mean voltage, it's about 12 volts. The intensity is going down a bit. So 11.9, that's close enough. it's still 0.6 amps. So that would give 12 volts times 0.6, 7.2 watts. That's still pretty acceptable, actually. That's actually what this thing seemed to be regulating to. And what would happen if it went down further? Keep in mind that as the voltage goes down, the intensity will go down, the current draw will reduce as well, but that's good with sealed lead acid batteries, because as the voltage goes down, you don't want to go down too low, or you can end up damaging the batteries if you over discharge them. So let's turn it down to, say, 10 volts, which is actually probably going a bit too far with a sealed lead acid. What would we still have? 220 milliamps. So it would still be rated, at that it would be about 2.2 watts, which is still, you know, that's putting out a good amount of light still. So it does suggest that, you know, for utter simplicity, if you don't want any active electronics, you could probably get off with a 3 ohm resistor, or probably better still, an industry standard value like 3.3 ohms. And the power rating, I'd rate it at least 3 watts, but I'd be tempted to go for one of those boxy ceramic resistors. Oh, that's quite a bright LED actually. A box of ceramic resistors and glued into the back. So I'd probably go something generous. I'd make it about 5 watts probably. 3.3 ohm 5 watt resistor stuck in the back. Now that may, you know, the current will vary between different LEDs. Some of them have very slightly different forward voltage. But in general, this one seems to have a fairly average one. So that would suggest that, you know, it would have been viable to use the resistor, but it wouldn't have had the benefit of as wide a voltage range as if you're using the electronics. But for a standard 12 volt car battery going between, say, 12 volts, 13.8 volts, it would provide an acceptable solution, just the fixed resistor, and it would certainly keep it really simple.